Hello everyone, welcome once again to Mathematics Me. This is a program that we have designed in order to help students in the study of mathematics. And I know that you will really like this program. A meal from mathematics will help you a lot. It will make you mathematically healthy. Today on Mathematics Meal, we are still looking at theory of logarithm. We wrote out 5 objectives about theory of logarithm, and so far we have looked at the meaning of logarithm, we have looked at the laws, and now we are on simplification of terms and expressions involving what? Involving logarithm. Now, we also said that there are 3 different cases in the simplification of terms and expressions involving logarithm. And we are still on case 1, which is the case when we have just one log operator. There are other 2 cases which we are going to consider subsequently. That's the case when we have many log operators and also when we have division of logarithm. Now, in the first case, which is the case when we have just one log operator, we say there are 2 methods that can be used in simplifying such terms or expressions. If you want to simplify this, we have 2 methods that we can use because we have just one log operator. So there are 2 methods. In the last video, we considered the first method, which is indicia method. And today we are looking at the second method, which is the ancestors method. Remember that we say that no matter the method you decide to apply in solving any of these problems, you're going to arrive at the same results. Okay. In the indicia method, we look at the various steps that are involved. And also in the ancestors method, we are going to look at these steps. Now, we have about 5 steps that we need to take in order to simplify log expression or terms that contain one log operator. Now, there are 5 steps involved in the ancestors method, and we're going to follow those steps in solving problems. So let's see if we can just write down 1 or 2 questions, and then we now follow the steps. What examples? Let's say simplify the following or evaluate the following. So we have this 1 log 32 in base 2. I think we solved this problem when we looked at the indicia method. Now, if we want to simplify this now using ancestors method, remember this is a typical case of when we have one log operator, just a single log operator. How do we go about it? We said there are 5 steps that we are going to take. I gave a general rule last time when we looked at the indicia method. We said that decimal fractions should be expressed as vulgar fractions. We also said that mixed numbers should be expressed as improper fractions. And also we mentioned an important point again, that the square root of any number is that number raised to power of 1/2, that's power of half. These general rules are also applicable to the ancestors method. They are not just applicable to indicia method alone. So in the ancestors method, we'll say that the steps involved are: first, take note of the term or expression and identify the ancestor of the base and the number. So to solve this, we take note. The number we have is 32 and the base is 2. We have taken note of this, the number and the base. And then identify the ancestor of the base and the number. So what is the ancestor of 32? The word ancestor, we know what it means, like your great-great-great-grandfather, your origin, where you started your journey. So where did 32 start its journey? It's actually from 2. The ancestor of 32 is 2, because 2 is the number that gave birth to 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 32. Oh my God. So 2 is the great-great-great-grandfather of 32. So the ancestor of 32 is 2, and 2 already is an ancestor of itself. So we have identified the ancestor of the base and also the ancestor of the number. So what are we going to do with it? The identification is not enough. That's why it's a stepwise approach. So what are we going to do after identifying the ancestors? They say we need to do another thing. Express the base and the number in index form using their word ancestor. That means I need to write 32 in index form using its ancestor. And when I do that, I will have 2 raised to power 5. Plus 2. 2 is already the ancestor of this cell, so I'm not writing it again in index form. I'm not writing it again in index form. That's what this step says. Express the base and the number in index form using their word ancestor. We know 32, when we do continuous division using 2, we have 16, 8, 4, 2, and 1. 1, 2, 3, 4, 5. That's why it's 2 raised to power what? 5. So, we go again. We just finished with the second law. So we say, using appropriate law, the second step, sorry, we are now on the third step. Using appropriate laws or law, remove the word power on the base and the number if there is any. Obviously there is. We have the power here. We have the power here, power of 1, but we don't need to remove it because any number raised to power of 1 is still that number. So, which law are we going to use to remove this power here? We remember the third law of logarithm. We say that log m raised to power p in base a is same thing as p log m in base a. So when the power is on the number, that same power is same thing as the number multiplying the what? The log. So if I have a log term like this, I can decide to write it like this. That's what the third law told us. So I have this like this. So for me to solve this problem, I need to write it like this. Because writing it this way will help me in the simplification. You see why? Why we have to put it like this. So this and this are the same. So I can write this in this form. I can also write this in this form. Now, there is a demand that when I have this power on a number, I can put it like this. And also when I have this multiplying this, I can put it like this. Now, in this case, now there is a demand not to leave this, leave the power on the number. We need to write it like this because we are trying to simplify this particular expression. In some other question, there may be need when we have this, we have to bring this to become the power of the number. In other words, when we have this, we can write it like this. There are questions that will demand that we move it from here to here. But in this case now, this question is demanding that we move this from here to here. That means from here now, we're going to have 5 log 2 base 2. So that's why they say using appropriate law, remove the power on the word, on the base and also on the number. So we have removed this power on the number using the third law of what? Logarithm. Okay, they say it again. After you have done that, notice that the base and the number are now the same. Okay? And that's true. Can you see that? The base and the number. Look at the base. Look at the number. They are just the same now. 2 and 2. They say now, finally, using appropriate law, remove the log operator and simplify to obtain your answer. When the number and the base are the same, you remember the fourth law. Log a in base a is 1. Logarithm of a number to its own base is equal to 1. That means log 10 in base 10 is equal to 1. When we treated laws of logarithm, we spent time explaining this. So, having said that now, we can now say that log 2 in base 2 is 1. So we have 5 times 1. This multiplying this. The whole of this log 2 in base 2 using the fourth law is equal to 1. So our result becomes what? 5. Okay, we need to take another question. We need to take another question now, quickly. So let's go. Let's pick this now. Let's say I have log 27 in base 9. Log 27. Log 27 in base 9. We still follow our steps. So let's go. We have log 27 in base 9. Okay. Now they say, take note of the term. We have done that already. Identify the ancestor of the base and the word and the number. Identify the ancestor of the base and the number. Now look at the base, look at the number. Who is their great-grandfather? Who is their father? Who is their great-grandfather? Now, between 27 and 9, they have common ancestor, and that ancestor is 3. It's 3 that gives birth to 9, 3 times 3 is 9. It's 3 that also gives birth to 27, 3 times 3 times 3 is 27. So we have identified the word, the ancestor, as word 3. And we're going to use that ancestor. Express the base and the number in index form using their word ancestor. So let's write this in index form, write this in index form using their ancestor. So we're going to have log 3 raised to the power 3 and 3 raised to the power 2. Oh, beautiful. We have done that. Then, what's the next thing we do? There is a power here and there is a power here. We are done with this. They say using appropriate laws, remove the word power on the base and number if there is what? Any. Okay? Remove the powers on the base and also on the number if there is any. So we look at this. What's the power? What's the power here? 3. What's the power here? 2. Now, we have seen how we can remove power from the number using the third law of indices, of logarithm. We have that. So this is P log n base 3. Now, when the power now is on the base, we have log n a raised to the power n, for example. Now, the power on the base, the power on the number, let's go back to this again. The power on the number is the same thing as the number multiplying the log. Look at this. So this and this are the same thing. So I can write it like this. But when this will not help me in simplifying my expression or term, then I have to put it in this form. Then I'm going to do the simplification. The same thing here. When the power is on the base, that power is the reciprocal of the coefficient of the log. So you see, in this one, we are not inverting it, but in this one, we have to invert it when the power is on the base. It's just a law, and we saw it when we treated the laws of what? Logarithm. So we are going to apply that here. So 2 laws, one the third law, the other one the 6th law. So we are going to apply these 2 laws now, on this and this, and then we have our answer. So the power is on the base. When we want to write it in alternative form, we are going to write it as 1 over 2, then times the power is on the number is just 3 log 3 plus 3. That's what we have. So combination of this and this, that's what we just combine. The reciprocal is because the power is on the base. This one is on the number. Very simple. Just follow what we are doing. And then notice again from our first step that the number and the base are now what? The same. So the logarithm of 3 in base 3 will give us what? 1, using appropriate log. Log of a number to its own base is equal to 1. So we have 1 over 2 times 3 times 1. 1 over 2 times 3 times 1 will give us 3 over 2. That will finally give us 1 over 1 over 2. Okay. Right. So far, so good. We still need to take 2 more problems. We want to use this and this and actually illustrate that it's possible to handle problems that involve square root and also to handle problems that involve what? Decimal. So let's look at that. Let's look at the 2 questions now. Okay. Right. So we have this. We have question number 3. Evaluate log with 8 base what? 4. So how do we go about this? We need to solve. So log with 8 base 4. We have taken note of this, so we need to identify their ancestor. But we have a problem. What's the problem? The square root sign. So we need to first of all write this by removing the square root sign. How are we going to do that? Remember our rule that any number, the square root of any number is that number raised to power half. So square root of 8, we can write it as log 8 raised to power 1 over 2. Beautiful. Beautiful. We have this. So we have solved our first problem by making sure that we take care of this square root sign. Okay, that's why we gave those rules. So that when you are solving problems, you encounter that you say, you know, it's not every time you think within the box. You can think outside the box. You know, this one is not logarithm now, the square root of it. It's not part of logarithm, but you use the knowledge of indices applied there. So you can still think outside the box if you want to solve the problem. So identify the ancestor of 8 and 4. The ancestor of 8 and 4 is 2. So now we have known is 2. Then what has express the base and the number in index form using their word ancestor. So if we write 8 in index form, 8 is actually 2 raised to the power 3. 2 times 2 times 2, that's 8. So, but remember we have part of half. 2 raised to the power 3 is 8, but there is part of half that has been there. Then 4 is 2 raised to the power 2. Okay, beautiful. In indices, when we have part of power, this is a power, this is a power on the same number, so we multiply the powers. So we're going to have log 2 raised to the power 3 over 2 now. Log 2 raised to the power 3. So repeat my log again. Log 2 raised to the power 3 over 2. And there's 2 raised to the power 2. How did we arrive at 3 over 2? Because we have 3 here times 1 over 2. That's 3 times 1 over 2 will give us that. So what do we do? Remove the powers again. There is 2 here. You know, we have explained that when the power is on the base, it is the reciprocal. So we have 1 over 2 times the power is on the number, nothing changes, it's still 3 over 2 log 2 in base 2. Okay, beautiful. Very beautiful. So log 2 in base 2 is 1, because notice that the base and the number are now the same. So it's 1. So if we do that, we have 1 over 2 times 3 over 2 times 1. And finally, 1 times this is 3 over 4. So log square root of 8 in base what? In base 4 will give us 3 all upon what? All upon 4. 3 all upon 4. Okay, we still need to take one more. We have seen a case where we have ordinary numbers, now square root. So let's take a case where we have a decimal. So we have a decimal. And after that, we are going to give you some questions that you are going to solve. Oh yes, some questions that you are going to solve. All right, this is our takeaway question. So let's look at the fourth question now. Let's say we have log. Let me use this log 0.2 base 25. Okay, let's solve that. Okay. We have a decimal, so we need to change the decimal first to a fraction, because we have something outside our steps. So let's handle that thing so that it will clear the way for us to start applying our steps. 0.2, we change it to decimal is 2 over 5, sorry, 2 over 10. Each decimal represents what? A 10. So we have just one decimal place, so it represents a 10. And when you break this down, you have 1 over 5, 1 over 5. So 0.2 is the same as what? 1 over 5. So we have 1 over 5. So let's write it log of 0.2 base 25. Something as log 1 over 5 base 25. Oh dear. We have another issue. This is like a fraction, but this is a whole number. What's their ancestor? I need to try as much as possible to write this as an integer anyway, no longer as a fraction. So that's where the challenge is. But it's not a problem. Let's remember the laws of indices. The fourth law of indices says that a raised to the power minus x is 1 over a raised to the power x. That means when I have a negative power, it's the reciprocal of the number. In other words, when I have reciprocal, I can write it as negative power in terms of negative index. So if I have 1 over 5, if I have 1 over 5, we are saying that a raised to the power minus s is 1 over a raised to the power s. We are looking onto this, right? The same way the Bible says, looking unto Jesus, the author and the finisher of your faith. So we are looking onto this particular law in order to handle it. So we have log 1 over 5. 1 over 5. Now 1 over 5 is something as 5 raised to the power minus 1. Because the power of 5 here is 1. If a raised to the power minus s, so we are written it here, is equal to 1 over what? A raised to the power s. It means when this comes this way, it's written like this. When you want to write it this way, it is written like this. So if I have 1 over 5, this thing 1 over 5 is something as 1 over 5 raised to the power 1, right? So if I want to write it in alternative form using negative index, it's 5 raised to the power minus 1. Okay, so that's settled. Then the ancestor is still 5, so I can write 25 as 5 raised to the power 2. I don't have much to worry again. Just creating space. So when the power is here, is reciprocal. We have seen that over and over again. The power here, we just have minus 1 log 5 in base 5. And log 5 in base 5, notice they are the same using appropriate law. Log 5 in base 5 is 1. So we have 1 over 2 times minus 1 times 1. That will give me minus 1 all of that. Minus 1 all of that. So that's beautiful so far. I believe you have been enjoying the meal so far. You have been enjoying the meal. And I know that it has nourished you so far. Alright. This is where we're going to end this particular episode. In our next episode now, we are going to solve a variety of problems. After solving those problems, we will now give you a question that you need to solve. We'll just solve 2 or 3 problems and then we'll now give you your takeaway question that you need to ponder upon. Keep watching Mathematics Meal. Remember, a meal a day has a way of driving away mathematical foolishness. Thank you and God bless you.